Hello there. Today we'll be doing the longest strictly increasing then decreasing sublist. You are given a list of integers nums. Return the length of the longest sublist such that its length is at least 3 and its value are strictly increasing then decreasing. But the increasing part and the decreasing part must be non-empty. So let's take a look at example 1 and look at what they're trying to tell us. So example 1, we have 7, 1, 3, 5, 2, and 0. And our output is 5 because 1 increasing, 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 decreasing, decreasing. So we have a total of 5 numbers that are increasing then decreasing. In example 2, we have none because it's, 1, 2, 3 doesn't decrease. 3, 2, 1 doesn't increase. And for example 4, we have 1, 2, 1, 1, and we have a 3 because of 1, 2, 1. So it is technically impossible to get any item that's going to be have this particular this particular, let's say, characteristic of it increasing and decreasing without at least 3 values. So I think we can ignore that sort of case. So there are 2 ways that I would like to go through this particular problem. The first way I want to do this is I want to divide the problem and then conquer it. So what I mean by that is that I'm going to get all the items where the increasing whereas increasing ends. So 1, 2, 3, 5. That's a particular point at which it increases and it stops increasing at that point. I'm going to save that point and get the length. Then I'm going to get all the items where it's decreasing, like 7 down to 1 and 5 down to 0. So that's where it starts decreasing. And I'm going to get from that particular point decreasing the length. If I add those 2 up together, I will get a total of 5 because I will have a increasing length of 1, 2, 3 and a decreasing length of 1 and 2. So that way I will have my particular answer by dividing this problem and going through the cycle twice. Another way is just to map out the characteristics of this particular problem. By that I mean if we can map out any circumstance that this occurs using code, like just straight up map it out, we can also get the answer. So I like this problem because it's a lot of coding athletics, and I want to just do let's say I think I want to do this in 2 parts, but if it's quick I'll do it in 1 part. So let's start with divide and conquer to get ourselves started, and then we'll do the 1 pass. So first things first, we want to do an increasing end and get that dictionary. So is increasing equals false and length is equal to 0. So for I in range of length of nums minus 1, if nums I is less than nums I plus 1. So what that does is that we're looking at if we're going to find out all the cases in which this happens to be true, which is the previous number and the next number is going to be greater than the current number. So we're going to set increasing to equal to true, and then length is plus equals 1. Else, if it's increasing, and we know that by it's no longer increasing, it's decreasing, then we're going to set the is increasing to false, and we're going to set increasing end. I want to set the increasing end of I, this current, to length plus 1. Then grab that extra that current item, and length is now equal to 0. All right, so we got the increasing ends. Now we're gonna do the decreasing starts. Decreasing starts equals dictionary is decreasing equals false, and length is equal to 0, but we also need one more item called start. So for same thing, I in range, length of numbers minus 1. So if nums of I is greater than nums of I plus 1, then yeah, and it's not decreasing. So it's not currently decreasing. We're gonna set the start point and set that it's decreasing now. Otherwise, I think we can set this to 1. It makes sense. Yeah. Actually, we can just do that instead. Better code, right? So otherwise, it is it's currently decreasing, and it continues to decrease. So we just want to increment the length plus weight equals 1. We don't want to reset the start point. Then otherwise, if it's no longer decreasing, and it was decreasing before, then we can say is decreasing equal to false. Decreasing start equal to start equals length, and length is equal to 0. Start is equal to 0. Well, all right, so that's all. There's one more thing that we need to do. That is, we need to get that particular start item at the end if it's continued decrease, because we only set the decreasing when it stops decreasing. So if it never stops, then we have to set it one more time. Then we can now start our max length equal to 0 for I in increasing ends dot keys, and if I in decreasing, if they have the same start and end spot, max length is equal to the max of max length, and increasing ends I plus decreasing starts of I. Then we can return the max length after all the work. We have an issue. Increasing end is not defined. We spelled it wrong, line 14. Run. We have a failure here. Let's see what's going on. So best thing to do is print it out. Oh, it looks like the decreasing starts are not populated at all. There must be an issue. So 1 and 2. So why is it and starting at 1? Oh, I see. Okay, that was solved. That was interesting. I think I made a mistake there with start point. Well, I think this video has gone pretty long. We're gonna come back with a part 2 for this particular problem, and we're gonna have a much better solution this time around. This particular solution is rather cumbersome, but it's a little bit easier to like wrap around like in my head. So that's why I presented this one first. But the code is so much more messy. Well, if you enjoyed the video, please like and subscribe. And if you have any questions about this problem, please leave a comment in the section. And if you want more videos, please check out the link in the description below. I will have algos and what I'm doing in iOS there. And thank you very much for watching.